example 1b, we're going to graph y minus 2 equals x squared. So I prefer to get y by itself. So I'm going to rearrange this equation. I'm going to move 2 over here, and this is going to be x squared plus 2. So this is a parabola, x squared, shifted up 2. So you would have graphed these before in our grade 11 pre-cal course. So to do that, I'm going to start with the vertex. So this is what the graph would normally look like over here. We're going to take this vertex and we're going to shift it up 2. So I'm going to plot the vertex up 2. From there, I could count each point up 2, but I just know that shape now, and I want you to get practice using that shape again of from the vertex, when you're graphing a parabola, you go over 1, and then you square however far you go over. So over 1 squared is 1, so I go up 1. Over 1, up 1. Over 2, up 4. 1, 2, 3, 4. And we're always starting at the vertex when we say that. So I go over 2, I square that, I go up 4. So it's symmetrical, meaning it's the same on the left and right. If I were to have gone over 3, I'd go up 9 from there, but I'd be off the grid. Again, remember your arrowheads. Let's compare this now with a horizontal stretch. If the value, we call this the h value now. We call these parameters, the h and the k value. If it's within the brackets with the x, then it applies to the x values. So this would mean right 3. Now, you might think that seems a little bit backwards, but it's not. Let's just quickly graph it, and then I'll explain that a little bit more. So you go to your vertex, where it would have been 0, 0, I'm going to go right 3. So it's the 3 on the x-axis now. And then again, over 1, up 1 on both sides, over 2, up 4. Over 2, up 4. Over 3 would be up 9, but again, just because I'm off the grid, I'm not going to bother plotting that point. And I have that U shape. Make sure it's a U and not a V shape. On there, it's a curve. Okay, so let's just review again. Remember that the actual equation itself has a minus sign in there. So that means if the h value was the number 3, when we plug 3 into there, it looks exactly how that question was typed. So when h is a positive 3, it looks like a minus sign here. It looks like negative 3, but really it's because this was minus. What if we put a negative number in? So like, what if I put h equals negative 3 in, for example? Well, when I do that, it would be x minus negative 3 squared. And of course, minus and a negative would be simplified to a positive. So when you see a plus sign, it's actually going to be the h value is negative 3, so that would be left 3. So I always say it appears to be the opposite sign. The actual h values are still true. If the h value is 3, it's to the right. If the h value is negative, it's to the left. Okay, but it appears to be the opposite sign because in the equation itself, you have a negative sign. Let's quickly just review what I have here as well. This can also be expressed a little bit different. If I didn't write the first equation as y equals x squared, but instead I wrote it as f of x equals x squared, just saying that I'm labeling this function x squared, I could have written instead of x squared here, I could have wrote f of x. So if f of x and x squared are the same thing, I can replace wherever x squared was typed with f of x. So this would mean that the graph y minus 2 equals f of x, or again, I prefer it rearranged, f of x plus 2. And what this means is this is the graph of f of x, which we have said f of x is that parabola shifted up 2. Here we would write it this way, y is equal to f of x minus 3. This would mean the graph of f of x, which in this case is x squared, shifted to the right 3. So we use f of x notation to represent any kind of function. If this is used here for b and c, then f of x must clearly be identified. Sometimes it's identified by just a picture and you don't need the equation, and we can label this f of x. So we'll come across this quite a bit in this chapter as well.